Let us look at proposition number 31 of book 11 of Euclid's Elements. The proposition says parallelepipedal solids which are on equal bases and of same height equal one another. Okay, now to prove this, let's split it into two parts. In the first part, we will look at the case where the legs of these solids are perpendicular to the bases. So angle ALB is right angle. Angle CRD is right angle. So first we take care of that particular case. The first step in the construction part of it is we are going to copy this parallelepipedal solid at R. If you notice, there is this solid is at an angle to this solid. So let's create another solid which is equal to this solid, but it is in a straight line. Extend Fs and extend dr. Then we will extend Vd and Wu, so that these two lines will intersect at this point. These two lines will intersect at this point. And we join EY. Extend QF. We draw a line through X parallel to Fs. And let's mark this as I. Same thing we do here as well at the bottom. We extend PD. Through T, we draw a line parallel to DR. And we mark the intersection as A. And we join AI. And we mark the intersection of this line AT with the straight line UW and mark it as B. And now we extend IX to intersect with EV and we mark the point as C. And finally, we join CB. Now here, this solid AE is equal to solid XU, because that is how we constructed this solid XU. Now solid XY is equal to solid XU. How can we say that? Because they are both on the same base. And what is the base of these two solids? The base is Rx. And the legs that they stand on are the same straight lines. So these legs stand on this straight line. These legs stand on this straight line. That is WY and EV. Now, solid XY is equal to solid AE. Why? Because this solid is equal to solid XU. XU is equal to XY. That means XY is equal to AE. Okay. Now, parallelogram RUWT is equal to parallelogram YT. That means the base of these two solids is equal. How? Because parallelogram RUWT and parallelogram RYBT, they have the same base, that is RT, and they are between the same parallel lines. Now, parallelogram YT is equal to CD parallelogram. How? Because remember, our proposition says the bases are equal of AB, solid AE and solid CF. That means AB is equal to CD. Now, AB is equal to UT because we copied it. And we have just now shown that YT is equal to UT. That means YT is equal to CD. Now, CD is to DT. Remember this at the back? a new parallelogram has been constructed, and that is part of the solid PCTA and part of YBAD. So, which means we can say parallelogram CD is to parallelogram DT as parallelogram YT is to parallelogram DT. But we constructed this DT parallelogram by extending parallelogram CD and parallelogram YT. We know that the solid CF is to solid RI as base CD is to base DT. Solids are proportional to their bases. Remember the reasoning? Solid CI, this entire solid CI is cut by the plane RF parallel to opposite planes. So that is how this proportionality comes. Similarly, solid YX is to solid RI as base YT is to base DT. Again, solids are proportional to their bases. So that means both CF solid and solid YX, they are both proportional to the same solid, that is Ri. Since they are proportional to the same solid, that means they are equal to each other. So solid CF is equal to solid YX. But YX is equal to UX. UX is equal to AE. So which means CF is equal to AE. So we have shown that parallelepipedal solids which are on equal bases and of same height equal one another in the case when the legs are perpendicular to the bases. Now we have to look at the other case when they are not perpendicular. So let's say these two solids are given. We have to prove that they are equal to each other. Now these parallelepipedal solids are on equal bases and same heights, but they are at an angle. The legs are in an angle. Okay, so a little bit of construction. Let's do that. What we are going to do is construct a perpendicular solid. Now to construct the solids perpendicular to the plane of reference, what we'll do is draw perpendiculars from G, from E, from K, and from M. And we'll take the intersection of these lines with the plane of reference. And now we will complete the solid. And now we can hide off these perpendicular lines. Now, same thing we will do with respect to this solid as well. We draw perpendiculars from S, F, Q, and take the intersection of these lines with the plane of reference. And then we complete the solid and hide the perpendiculars. So that's the construction part. Now let's see how this helps us in proving that these two solids are equal. Now, solid KV is equal to solid QI. Why? Because they have equal bases and legs are perpendicular to the bases. Now here the bases are EKGM and FQNS. Now solid KV is equal to solid AE. Why? Because again, same base, EMGK, same height, legs do not stand on the same straight lines. And this we have proved. Similarly, solid QI is equal to solid CF. Again, same basis, same height, and legs do not stand on the same straight lines. Again, one of the previous propositions we have proved this. Now here the base is NQFS. So this is equal to this is equal to this, KV is equal to QI. So which means if these two are equal, KV and QI, and KV is equal to AE and QI is equal to CF, that means AE is equal to CF. So that is proposition number 31 of book 11 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.